The third COVID wave is here in India, just as we have rolled out what we prefer to call precaution doses of vaccines. So, once more questions about immunity, about boosters, immune modulators, and the lifespan of COVID antibodies are top of our minds. So, to discuss all of that, we have with us today Dr. Shiv Pillai, Professor of Medicine and Health Sciences and Technology at Harvard Medical School. He's the director of the Harvard PhD and MMSc Immunology programs. His group studies T-cell, B-cell collaboration and its relevance to autoimmune and inflammatory diseases. All of these are words that we have literally lived with for the past 2 years. Dr. Pillai grew up in India and went to study medicine at Christian Medical College in Vellore. He then received a doctorate degree in biochemistry from Calcutta University. He also has a unique poetic take on immunology. We will come to that in a bit. Welcome, Dr. Pillai.
Hi, how are you?
I'm good, sir. Thank you so much for making the time. So I'll start off with something I heard you saying in one of your lectures. So I think you were talking about immunology in the context of COVID, and there you had said that the COVID story is steeped in tragedy. I want to know why you think so.
Well, I mean, in the original era, it was steeped in tragedy, so much so that people did not protect themselves. Governments did not act in time. We had people having mass meetings. This is true in the US and across the world. I'm not saying any one country did it wrong, but some countries did it right. Some countries had better surveillance. Some countries even managed with dense populations to track and trace and keep things under control. So that gave them time before vaccines arrived. So clearly, I can speak for the US. We have fantastic hospitals, fantastic research, but very disjointed public health systems. And even in the UK, which has good national health, they just didn't take the right decisions. And so there are some countries which did a much better job. So the tragedy comes from the very many millions of lives. I mean, everything is an undercount. We lost many millions. Many of them were avoidable deaths. There's no question about that.
And how do you assess India's response?
It varied. Initially, it was maybe, there wasn't enough information. So going on, the lockdown was based on limited information. At least there was proactivity. Maybe it wasn't as well planned as it should have been and all. I'm not faulting anybody for that, but that clearly created dislocation and problems at that time. But subsequently, I think I remember, because I follow cricket, I remember seeing some video of T. Natarajan after the Australian tour go back to Salem, and he was being carried around by people all unmasked in the streets. So I said, what is this? Do people not informed enough to know that this is not the right thing to do? Because, I mean, probably a lot of spread happened even there, even though it's outdoors. People go indoors from outdoors. I mean, if you have big religious gatherings and you then go indoors, people have to live somewhere. So I think those decisions, all across the country, state government, central government, everybody, could have been better informed. Maybe in the US, it was the same thing. Half our states didn't take things seriously, half did. So I think there was never any doubt from the science that we were then dealing with something that was highly transmissible, that we had not got rid of. There was no way we had gotten rid of it. I'm not sure how much information. There was information in the world. I mean, I'm following Brahma Mukherjee from Michigan for a long time. And I mean, there was information that in India, cases were going to rise. They were rising. But same thing in the US. So I won't blame one country. All over the world, people didn't do as good a job in government as they could have, with better information, more science, more rootedness in science. You have to have willingness to respect some information and gyan and buddhi. So, that's important.
So, and have we done better during the third wave that's currently ongoing? So I guess we can't definitively say anything.
So, I mean, the reality is I do because of family. I come to India and I love India. And, I teach in India. These are all things I do. I think people are not as serious as they should be. This is a fault of the public as well. I mean, people don't wear masks properly. They don't know about it. Sometimes they don't wear masks. The way they are wearing the mask is going to do nothing for them. So I'm a little concerned about amount of information people have on what to do. And I understand how people are tired and don't want to be doing this all the time. And life has to go on. And we have to find a way to live with all these things. All that is true. But we can avoid the large indoor gatherings and things like that. So I'm not sure how much this is an issue of public education. It's not just, it's a broader issue for us over a longer time. And it's not one part of the country. Everywhere in the country, there's these issues that come up. So obviously we have done better. Vaccination has been amazing. India has done a great job with vaccination. India has great, vaccine companies, amazing companies. India has great pharma. I'm very hopeful now with, I've heard that Cipla will be making Paxlovid. And that Paxlovid will not be the answer to everything, but it will help. So with these kind of measures, I think we will be, and given the fact that Omicron is probably a much milder virus, hopefully we'll get into a much better shape. And I'm very hopeful. I'm hoping things in India are going to be great in a couple of months and people will settle down and public health will keep its eye on the ball because, we can again have waves. South Africa did a great job in just picking up, Omicron. I mean, I know those people in South Africa because of our connections with Durban, and their science was excellent there. Now, India has that science, whether it's all in the public sphere or not, I don't know, and whether it's being used as much, I don't know. There's some brilliant people in India, but I think that's what you need. You need monitoring. It may be fine. Maybe Omicron will become like the common cold virus, which, by the way, doesn't give us much immunity when the coronaviruses are concerned. We get repeated infections, and then we will probably get repeated infection. But then who knows? One day we may get another severe variant or another virus. So that sort of infrastructure must be built in. India has amazing intellectual possibilities. It just has to harness them to be organized. That's all. So that there is a way to pick up these things. And we should be doing exactly what is being done in South Africa, where people are thinking and doing the analyses and so on. Right. There's differences. But I'm not saying we are good. In many ways, we've been great.
So talking about Omicron, mild disease, all of that, this is something I've been wondering. So this time so far, and I hope it stays that way, we have been seeing patients who are recovering faster, whose symptoms are not that severe. There seems to be less of the long-term effects that we saw last time. Is this because Omicron, as it is said repeatedly, Omicron is mild, or is it because a lot of Indians are now double vaccinated?
I don't think it's the latter. Okay, so I think the main factor with Omicron, and we thought that in South Africa, because there was a previous huge Delta wave, that there was enough immunity there, not from vaccination alone, and that maybe that's why Omicron is less severe. But there's a lot of biological data now coming out that Omicron, actually, though it is highly transmissible, it can get into cells faster. Its incubation period is shorter because it just moves from cell to cell much faster. It does not seem to affect the lower respiratory tract in the same way as it affects the trachea. So the windpipe gets affected, but actually the lungs are not being hit. And the real problem came because so much replication occurred in the lung with the original viruses, and that caused the severe cytokine storm and then the attendant problems. So I think Omicron biologically is more like, in some ways, like a common cold coronavirus. It provides some immunity to Delta, but not as much as you want. So, I mean, the question is, will we just have a big Omicron wave? And then we'll get some immunity to Omicron for a while, and then some partial immunity to Delta, which will fade. Be sure that from natural infection, it will fade. At that point, will there be a recrudescence of something like Delta or a variant of it? We hope not, but that is a formal possibility that we have to be aware of. that somewhere in the population, we still have some dangerous viruses floating around. And if they are in a situation where there's not enough competition from Omicron, they might be surviving somewhere. I hope not. I hope they're going away and that Omicron is displacing them and then they disappear from the population, which could happen, which is great, but it doesn't mean we won't necessarily have another problem. I hope not. I hope this is it, that we will get a big Omicron wave which is sharp. It's happening in the US, it's already going down. Massachusetts already started going down. Across the Northeast, it's going down. It happened in South Africa. So South Africans taught us everything, okay? And the same thing happened in the UK. It will happen here. It will happen in India. By March, I think you'll see it'll be down, right? But let's hope it stays that way. I'm hopeful. I mean, all of us want to have hope. All of us want to do the normal things again. So
yeah, totally. So, one of the problems we have faced with this pandemic is the transience of both. Now, as it turns out, both vaccine-derived immunity and infection-derived immunity. What makes us think Omicron will be any different?
So let me be frank and tell you that I don't think vaccine-derived immunity is that transient as people think it is. So in the case of SARS-CoV-2, the original virus, it really, in ways that because people have published all sorts of stuff, the reality is natural infection is not giving us that great immunity, okay? Adaptive immunity. Natural infection gives some immunity. If you then give a vaccine to that person, they will do much better. I've seen comparisons now of all ranges of vaccines. AZ is not, in terms of antibody levels, AZ, the equivalent of, so AZ is basically, in India, it's Covishield. Okay, and the equivalent of Covaxin in China exists from one of the Chinese companies. So I know people on the West Coast who've compared these vaccines from across the world. They've taken samples from Mongolia and elsewhere. So they have multiple vaccines being looked at simultaneously. Clearly, we're getting pretty good responses and antibody responses for a reasonably good time, and probably forever too. We don't really, I'll explain what I mean by that. From the RNA vaccines for sure. From the adenoviral vaccines, it's lower. But then there's probably pretty decent memory and T-cell immunity from all the vaccines. Maybe more from the mRNA vaccines or maybe more from the adenoviral vaccines for memory, but the antibody levels are really low. So now if your antibody levels are low and you got polio, you're probably fine. Or you got hepatitis, when I say low, it's all relative, right? So it's pretty good antibody levels, but they are not at the super high level that you want them for SARS-CoV-2. SARS-CoV-2, there's very few viruses that are so easily transmissible. Okay, I mean, there are other viruses that transmit easily, like measles and so on, right? But because we need to have, this is a virus that has so many other tools to evade us, we actually need a lot of antibody to be completely protected from infection. If you're vaccinated and you get infected, your chances of survival for all vaccines is probably very good. The chance of hospitalization is less. Remember, there's all that memory stuff that is coming in and some sort of a response will occur. You will probably, if you are vaccinated, what's the data? There's a beautiful study from the CDC showing that if you looked at hospitalized people in the US, and this is in the Delta time period, okay, it's not from Omicron, and that's what matters. In that time period, if you were vaccinated with, it was all mRNA vaccine, and you were hospitalized, or if you were previously infected and you were hospitalized, first of all, the chances of hospitalization were much lower if you were vaccinated than if you were previously infected. Previously infected, for most people, it was from 5 to 7-fold less. For older people, it was 20-fold less, meaning that having a previous infection did not protect you from hospitalization and possible death by about 20-fold if you're above 64. For younger people, it was from 5 to 7-fold. So there's an advantage from vaccination. Now, I agree that data I'm telling you is from mRNA vaccination, but I believe all vaccines provide protection at some level. the kind of very high antibody levels that we seem to need, we haven't had such detailed studies on other vaccines in the past. We do some small study and it's over, and another small study, it's over. So here we know we get levels, they're pretty good. They need to be very high to prevent you from infection. Like for Omicron, needs to be super high. Now, also the way vaccines have been done, scientifically, I would argue that if you actually gave all vaccines with a 6-month gap, you would probably get a really good response, especially with a foe that is as dangerous as this guy. Now, if it becomes Omicron only for a long time, which let us hope it will, then it may not be so important. It may be we will only vaccinate the elderly and say, we don't want you to get even the Omicron. Younger people, you'll get it, you'll be okay, you'll get it again. It'll be like common cold coronaviruses. We haven't figured out why we get them repeatedly. In the same year, you can get the same virus 3 times. Those viruses have been around for a long time. Okay, so this is possible.
Right. You mentioned the original coronavirus, the original SARS-CoV-2 virus. So I'm tempted to ask you this. What are your views on the origins of the virus? Where did it come from?
I mean, obviously it came from somewhere in Wuhan. That much we don't doubt. I think just by history, I would guess that it came from some animal source that we haven't identified. I would guess. Now, does that rule out that it was not from a lab? It doesn't rule it out. We don't know. I mean, everybody can state, many people are putting claims out and everything else one way or the other. I don't think anybody has enough information. And if people don't give you the information, we won't know. Okay?
Right.
If there was something came from a lab, I mean, it's theoretically possible. I'm not saying it's not possible. We don't have that evidence. Okay, so I think that's a moot point. Why make a big issue of it? No, I have absolute faith. Okay, I'm not talking about the government in China. I'm talking about the scientists in China. Because I know scientists in China, and there are very good scientists in China. There's no question about that. I don't think for the slightest anyone intentionally is releasing a virus. Okay, so not for the slightest. No one is. In fact, we got the sequence of the SARS-CoV-2 from a virologist in Shanghai who probably upset his government and put the sequence on a website in January of 2020. Okay, that's how that information got in. Somebody in Thailand saw it and, put 2 and 2 together from a patient from Wuhan would come in. And that's how we know that this is where the virus came from. So the scientists there, I have absolutely no worry about them trying to do something. Whether the authorities there are being open, obviously not. Okay, they've never been very open. That's the way that government functions. I'm not blaming them. I have no evidence to say anything like that. I would never say that this is it. I don't know.
Right. But you're saying that there is nothing about the structure of the virus that is, like we have heard this word being used in the past and then retracted also, smoking gun about the origins of the virus. There's nothing that can anything.
There is no smoking gun. Okay, absolutely none. The virus looks like viruses that can be found in animals. Okay, there is no question about that. I mean, there are bats which have viruses which are similar. Right. How exactly this particular, the original, what we call the Wuhan strain, the original first strain came out, which animal did it come from, or did it come from the lab? We don't know. And I think wasting time on that is like wanting to score points about something you can't answer, right? So I can't prove certain things. I'm not trying to prove certain things in the world, which I know no one can prove. Of course, if someone provided the evidence, okay, and went one way or the other, someone found it and the animal showed us the animal or showed us that, yes, I had it in the lab, I was working with it. We don't have that evidence. So I'm not going to, it's too much speculation and it doesn't help us. I think it's better that we do the science to help what we can do going forward. And everybody, whether they're in China or India or Pakistan or anywhere in the world, should be helped. That is the job of medicine and the job of research. I mean, not to worry about these issues now and to go forward with trying to understand what we can do correctly.
Right. So you talked about this a little bit earlier, but I want to know, are some vaccine platforms better than others against a virus like this?
So let me say that we have to be hesitant about giving a dogmatic answer, but I think there's been no vaccine platform that can be as quickly, generated or as efficiently giving us high-level antibodies as the mRNA platform. And to me, it's the most logical and simple platform to use. We just did not have, it took a long time, right? From early 2000s that people have figured this out. So I do think that is probably going to be the platform of the future, but let's wait. We have not got any proof that any other platform is doing better than it. In all the head-to-head comparisons I'm seeing, this is actually doing pretty well. Now, the one thing that has not been done in large numbers yet is the purified protein, which is what Novavax would do. With the adjuvant, the reality is most purified protein vaccines are okay in the past. I'm talking about for other pathogens. They're okay. They're not
What
bad.
are the other purified protein vaccines we know currently, sir?
Oh, there are many purified protein vaccines that we use. I mean, think of something like tetanus or diphtheria. We're actually using a protein and then modifying it and giving it. It's not bad. They work. They give us immunity. Now, the question is, maybe we can get away with pretty low levels of antibodies after 5 years with tetanus and diphtheria, but that wouldn't be tolerated here. So I don't know of a good head-to-head comparison to say that anything is better. So far, there is no evidence for that. So far, the evidence is saying mRNA vaccines are giving superb levels, very high level of protection, and they are the simplest technology in terms of just logical how they work. There is very little evidence for any side effects of note. Keep in mind that with both the adenoviral vaccines, we have some rare concerns. They're not serious concerns, but in some people, there have been issues. This is not a live vaccine. So unlike, live vaccines, the only vaccines for which you worry is a live vaccine like yellow fever or the oral polio in an immunocompromised person. Because in those people, those live vaccines can replicate and behave like a pathogen, right? So that's where we really usually worry about, you cannot even consider that. This is not a live vaccine. This is completely inert. It will make the molecule you want. It will make it for some time. It's not like it's not going to be there for some time, but then it will fade. We know it fades. And certainly, there's no logical basis to worry about. People say, oh, mRNA. I had scientists, it's very strange. I've had scientists come and tell me at a meeting, this is not somebody in academia, it was somebody in a company, but somebody came to a meeting and she said that, I don't want to have some RNA from something else in me. I said, have you ever had the common cold? Whenever you have the common cold, you have lots of RNA from viruses in you. That's normal, right? It's happening all the time. But you just think about it, we have so much in us all the time. This is actually scientifically, I think, the cleanest approach. If it holds up to being durable, which there are good questions being raised, but it's not that anything else was better, right? So that's why I'm saying I'm not sure that this is not a good approach. I think it's probably the best. It may be extremely durable. If I do the hepatitis B vaccine with this, right? And this approach has not been done yet. If it did, maybe that protection will last for 30 years and it will be perfect because I don't need that much. Most vaccines are judged by, did you get sick? Who's testing everybody to see, do you have some hepatitis B and you at some low level that we can pick up? That's what's happening with coronaviruses. You may not be sick, but we're testing and saying, you positive? Oh, you're positive. That's, so there's a difference.
Right. So a lot of the work done on immunology around HIV actually, I think, helped us during this pandemic. So do you see going forward, some of the work will help us in future pandemics? What are the sorts of lessons that we'll take into the next pandemic from this one?
Okay. I don't want to offend the HIV people because I work with a lot of HIV people. Okay, but let's be very clear. HIV platforms were set up. Huge amount of work is still ongoing to vaccinate almost all of it has failed. None of it has been successful in terms of actually having a vaccine that is protective. So yes, there were a lot of scientists around who had worked on HIV, who were working in immunology, who very easily moved into the SARS-CoV-2 world because they are used to studying infection. Many are from the infectious disease world. Some are scientists working on infection, immunologists. So that helped in a real way. So I'm not questioning that. Whether there was something we actually learned from HIV, yeah, it is true that my close friend and colleague Dan Baruch had developed a vaccine for HIV which did not work, which was based on the adenovirus vector. Okay. And the reality is that the folks in Oxford had also developed an adenoviral vector, which is what AZ and Covishield is about. But that was not related to HIV, by the way. I mean, they used it for other things. And this same vector has worked experimentally for Zika and so on, right? So even for Dan Baruch. So the reality is that mRNA vaccines had nothing to do with HIV. Okay, the mRNA vaccines were developed. They were aimed at MERS at the NIH with the Moderna collaboration. And in fact, BioNTech was not in the vaccine world; it was in the mRNA, therapeutic world, and it came into vaccination because it made sense, and they did it very well. So I don't think that if I think of what has really helped us most, it didn't come directly, not necessarily. So yes, of course, it helped that there are people who have a lot of people from HIV have started to work on this, but a lot of people from other fields too have started to work on SARS-CoV-2. So I think we shouldn't overstate that. Yes, we have learned so much human immunology now. Probably never in the history of our species have we learned so much about human immunology. They were very good virologists all along. Virology has been a driving force in biology for a long time, in molecular biology. So they're very good virologists. I don't want to say that they were there already, and we are lucky to have them. But yes, for human immunology, we did have a lot of opportunities to study humans in large numbers, to learn something. That knowledge will definitely help us. That knowledge that we've gained in this period. So even though, as I said, it is a time of tragedy, it has been a time of great intellectual learning across the world. I mean, even the common public has learned a little bit about immunology. I mean, it's good, but I'm saying in science, in the world of studying the immune system, we have learned a lot. And we have learned it on the backs, unfortunately, of people who have been very sick as well. So this is not something, we celebrate from that perspective. But yes, we have learned a lot, and this will help us. We will be much better prepared the next time around. If you think of the speed with which these vaccines were created, just means we have the ability, right? The next time it'll be faster. Maybe we will actually pay attention and put funding into creating, surveillance, pan-sarbecovirus vaccines. All of these things are going on. The people will be serious about this. So yes, I'm completely sure that we have learned a lot and we do better. Doesn't mean we have succeeded yet, right? We are still in a pandemic phase. So.
Right. Does the flu vaccine help in any way with COVID?
Yeah. Not with COVID. Flu vaccine helps you
against COVID.
So the flu vaccine doesn't help you against COVID at all. I have probably the effects are zero. I would not say that it helps you. It certainly helps you against the flu for some time, maybe for a few months. The flu vaccine is doesn't give you very long-lived immunity, and it's very directed against particular sets of strains. And we often don't get exactly the right strains right every year. So yes, flu vaccination, especially in elderly people, is important. In hospitals like mine, everybody has to be vaccinated against the flu every year. We just accept it as a rule, and we've been doing it for years, because I know that its protection is not amazing, but it's at least better than nothing. But this vaccine, amazing, in terms of what it's done so far.
Right. So you were talking about the common people learning immunology. In India, over the last 2 years, we've seen a thriving market of what is marketed as immune boosters, allopathy, homeopathy, across everything, Ayush, everything, every possible system of medicine has said that this boosts immunity. Is it really possible to boost immunity?
So everything you heard about, other than if you are not malnourished, okay, if you don't suffer from severe malnutrition, none of those things mean anything. So basically, I remember when I used to see patients when a long time ago when I was in Vellore, it's typical, and it's not unique to India. Everywhere in the world, people want to be told something, right? But they want to be told what to eat. And I would tell them, go eat a good masala dosa or eat a biryani, depending on the patient. That's more important than saying, I'll take a tonic and keep having that tonic. Now, obviously, if you don't have a good diet, it's a bad thing. You should have a decent diet. You should be well nourished. There is nothing that is really specifically going to aid immunity. Of course, if you lack vitamins, if you lack minerals, like everything else in the body, you won't function as well. So what is being done in India is being done everywhere in the world because people want to say, I'm doing something to protect myself. So I'm doing this. But this is like most of the business world, which keeps the world moving and is a good thing, it's garbage. Okay, I mean, this is basically, we are always buying garbage because we are affected by something else on TV and we go buy it, and we go eat. People watch a TV ad and go and eat in a particular type of restaurant. That happens all the time. So I don't think these are not meaningful things, but if it makes somebody money, it's fine. It's not harmful.
You mentioned that maybe in the future, we will only vaccinate our elderly. And this will. So how far away is that future? I mean, how long do you think we'll be stuck in this?
Let me paint you two scenarios. I mean, we all think about this all the time. One scenario is that we will get this wave, it will go away, and then after 6 months, we'll get something else, okay? And we are never really going to be protected, or there'll be that little bit of delta hiding somewhere, and that little bit of delta hiding somewhere will come back when immunity to Omicron fades. Because Omicron's immunity against delta is not that great, okay? That's been measured. It's good against Omicron. It's because Omicron is so different against Delta, it's there, but it's like at about 40% of what you want. So let's say it faded. And then somewhere there was Delta hiding. Or somewhere in the Amazon forest, there was somebody with Delta still, and there was no Omicron ever arrived there. It comes back. It'll come back. We'll be in trouble again. We have to worry about that. So that current vaccines, all of those things can work, okay? What is the alternative scenario? The alternative, positive, highly optimistic, maybe overly optimistic scenario is that by the mutation, and there's a history of this in animal viruses, by mutation from a highly pathogenic virus, no virus is trying to kill its host. All the virus is doing in terms of evolution is to have a place to survive and multiply, okay? Its job is not to kill us. Its job is to multiply well and move on to someone else. That's all it wants to do, evolutionarily. So if Omicron is actually able to displace Delta and any remnants of Beta or Alpha floating around and just take over the population, which it is doing quite well now, and then if the incidence of something else goes very low, it will die out, right? Because if you can't transmit to anyone else, you're not going to spread. Okay, then maybe Omicron will be the only SARS-CoV-2 left. Okay, then what will happen? Omicron immunity in the vaccinated might be okay. In the unvaccinated may be less okay, but it may be there because there's Omicron immunity to some extent. And then after 7 or 8 months, those people who never got vaccinated may get Omicron again, but it will be like the common cold again. Then this virus will start behaving like we have 4 known common cold coronaviruses, which share some similarities to Omicron. Not exactly. I mean, they're obviously not the same virus, but they share some similarities, structural also. So what might happen is that Omicron becomes the 5th common cold coronavirus. It does mutate a bit or something else happens, but it never gets highly pathogenic. It remains causing an irritation, a cold, like disease, maybe milder disease in younger people, maybe more severe disease in older people. So we will vaccinate, but we will be saying most important, we'll probably then make vaccines that are more specific for Omicron. And we'll say, okay, make sure elderly are definitely vaccinated, because in them, there's a higher risk still, okay? But then I would say everyone can get an Omicron vaccine after some time if we know that that's where we are. This is the optimistic scenario. Let's hope for it. It's not a certainty. There's nothing as a slam dunk in this kind of, situation. But there is a history of similar things having happened in animals, in pigs and so on. There have been viruses that are highly pathogenic, and then they, after a few years, morphed into something else, and they have now endemicity. And then we don't have so much of death. That's what we should hope for. That would be the most positive possibility. And I'm thinking maybe we'll get there. Maybe by the summer we will all be happily going around, we'll have some precautions, but maybe that's where we'll be. Let's see.
Let's hope that happens. It's been a very long 2 years.
I do hope that. I'm waiting to come back to India, So,
Right. So, finishing off, sir, would you recite one of your immunology poetries? I heard you on one of your YouTube lectures, and it was extremely interesting.
Okay. All right. I'll just do a random one. This is, okay. It is something that it's a little more lighthearted, but it's quite immunological. I hope some people will follow it, but it's about this. I have just discovered from reading Indian newspapers that in India, people pay more attention to the lives of movie stars here than we pay over here. Okay. So everyone in India who follows the newspapers probably knows about J-Lo, Jennifer Lopez, and Ben Affleck. And this is about them, but it's really about immunology. It's called the Ode to Ben and Jen. My noble cousin expresses CD4. He is a veritable cytokine store. But a DC's come hither and he's ready to go. The CD40 ligand, he just loves to show. My cousin's promiscuous, hits on passers-by, kisses the wrong B cells, then tells them to die. The right BCR can give fast the slip, shuts off caspase 8 by turning on flip. I grew up a cell of the CD8 kind. I was naive and aimless, bored out of my mind. I wandered like a cloud from node to node. CCL21 determined my abode. Along came a virus, infected the liver. Hepatitis B can sure make you shiver. My DC friends each picked up a sliver, and in the lymph node, I started to quiver. Is this the feeling that Ben had for Jen? Or when Romeo saw Juliet again and again? Peptide and class 1, and then some B7. I leap in delight. I'm in co-stimulatory heaven. I'm no longer a boring CD8 cell. I'm a killer now, baby. A real CTL. No fleeting feelings like Jen had for Ben. I proliferate like crazy, again and again. The liver beckons to me, and my brothers as well. We each form a synapse with an infected cell. With perforins and granzymes, the little clefts we fill. Oh, what passion to lock lips, but kill. Passion we have now, but once we did grieve. For siblings lost, forced to take their leave. They perished at the double positive stage. Cell structures they did strongly engage. They made some BIM and then felt weak. Their mitochondria started to leak. Cytochrome C bound to APAF1. Caspase 9 began to hum. We wept, but they chose not to fight. They vanished quietly into the night. I'm afraid that's quite immunological, but something that came to mind immediately.
Very interesting, sir. Thank you so much for that. And thank you so much for making the time for this interview. Thank you.
You're very welcome. Pleasure. Bye-bye.
Bye.